Today we are going to talk about inverses of a function, and we will be working with cubic, cube roots, square roots, and quadratics. So first of all, how do we find an inverse? Well, write down these steps. First, we're going to start with, we're going to replace the f of x, and we're going to change the f of x. And then after we change the f of x to a y, we're going to want to rewrite it, and we want to switch x and y with each other. Okay, now that we've switched them, we're going to use our algebra skills to now get the y by itself. So first we're going to move the positive 2 over. We're going to eliminate it by subtracting 2 from both sides. After we move the 2 over, now we have this by itself. We need to, what's the opposite of cubing something? We're going to take the cube root of both sides. When we took the cube root, we're now left with y plus 1 by itself. And so now we can subtract 1 from both sides. Now that we have the y by itself, we're going to go ahead and rewrite it. And instead of f of x, we are going to write this as the inverse function. This stands for the inverse function is equal to the cube root of x minus 2 all minus 1. So that's how we find the inverse of a cubic function. So the good news about cubic functions and cube root functions, so here is my original function, here is my inverse function, and notice that they are mirror images over this red dashed line. This red line is y equals x, and it's always a mirror reflection over. Now the domain and the range of a cubic function are always going to be negative infinity to infinity. So with inverses, one of the things we're going to stress is that the domain of the original is equal to the range of your inverse. But guys, for cubics and cube roots, we get very lucky here that no matter what, they're going to be negative infinity to infinity. Now let's go ahead and practice a cube root function. How do we find the inverse of a cube root function? So first we're going to start off by putting a y in place of f of x. Once we replace that, next we're going to switch the x and y variables. Now our goal is to get the y by itself. So what can I do first is add 2 to both sides. So we've added 2 to both sides, and now we want to basically eliminate this cube root. So basically the opposite of cube rooting something is to cube it. And if I cube it on one side, I must cube it on the other. Now this cube and cube root are basically divided to 1, and I'm left with x plus 2 cubed is equal to y minus 4. So again, we want to get y by itself, so we're going to add 4 to both sides. Now once we've written the inverse function, the last step is going to be to write it in function notation. But because this is the inverse, we write the inverse, which is a negative 1 right here. The inverse function is equal to x plus 2 cubed plus 4. Now, as we addressed in the last problem, for cubic and cube roots is that the domain and range are always going to be all real numbers or negative infinity to infinity. So we can make sure you guys write that down. So look at this graph. The original is in black, and it mirrored itself over the y equals x line, and it is still a mirror reflection. So with no restrictions to the domain. Okay. So now we get into square roots, and square roots and quadratics are going to introduce a new topic to us called domain restrictions. But let's first go ahead and find the inverse function of the square root. Again, we're going to go ahead and replace f of x with y, and we're going to switch the values at the same time. Okay. After we switch them, our goal is to get y by itself. So we're going to move the 3 to the other side by subtracting 3 from both sides. Now that that radical is by itself, that square root, I want to eliminate that, so I'm going to square both sides. And the last step to find the inverse is going to be to add 1 to both sides. So now that we found our inverse, we aren't going to leave it with the y. We're going to write the inverse function, so f to the negative 1x, is equal to x minus 3 squared plus 1. Now, this is where your domain and range get interesting. If you think about a square root has a restriction to that domain. So let's talk about our c value right here, which changed the domain. This C value, we always change the sign here, is really a positive 1. And the graph is going to go to the right forever, and so this is my domain. Now remember, the domain of your function is equal to the range of your inverse. Okay, let's talk about the range of the original. How low was this graph going to go? Well, this graph was going to go up 3, so this range is going to start at the 3 value. So this range is going to be 3 to infinity. And so the range of the inverse is equal to the domain. Now, hopefully you guys are questioning that the domain of a quadratic is not 3 to infinity. The domain of a quadratic is negative infinity to infinity. Well, the problem with that is that I can't have a whole quadratic and it be a mirror image over this line. So here's my original, and I'm mirroring it over, so I had to only use part of my domain. So I can only use my quadratic that starts at the vertex. Okay, so for now, I want you to pause this video here, and I want you to try this quadratic function on its own and find the inverse function. So then we can actually talk about that domain restriction since we can't look at the whole quadratic. So pause it here and try finding the inverse function. Okay, hopefully you got your inverse function correct. So now we're going to talk about that domain restriction since we can only look at half the quadratic. Now this quadratic is facing up because the a value is 1. And what I want to look at is half of my quadratic. So I'm going to start at the vertex. And the vertex is my c and d value. Remember your h and your k. Just depends on what letters you're using. So my vertex is -5, -3. With both those numbers are going to be used in my domain and range. So my domain is going to be only restricted to when it's greater than -5. So what's greater than -5? We can say -5 to infinity. So again, we're only looking at half of my domain. And the domain of my function is the range of my inverse, which makes sense because look at this d value. This graph was going down 5. Now the range, I'm going to start with this number, and the range was going up forever, so the range is -3 to infinity. And again, it's equal to my domain of my inverse, which makes sense because this graph was going to the left 5. We can look at that graph. Here's the graph and with the answers that we just found. So as you can see, here's my original graph, went to the left 5 and down 3. This is only half of my quadratic. So the actual quadratic would look like this. But because I'm looking for an inverse function, I don't want my whole quadratic. I only want half my quadratic that starts at the vertex and it's going to go to the right. And now this is a mirror image of my inverse function. So hopefully this video helped you understand how to find an inverse and how to work on the domain and range of a function and its inverse.